Oh, this is not fun.
No. Not with the amount of traffic that's here.
That street is closed.
You can go down this side. It's that side that's closed. I can't see past this stupid idiot.
Oh, come on, come on, come on, come on, come on. Oh, shoot, 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 shoot.
Just go. Yeah, you have to pay here, sweet. Go around the corner. There might be one on the street. Hi, folks. I am traveling right now because we have to go to, my daughter and I have to go to a dentist appointment. So I am doing this from my car. So, why didn't you take that one?
You have to pay that.
No, you don't. It's 2-hour parking. No, you should probably make the block and come back around. Sorry, folks. So, it's not 1 yet, but our appointment is at 2. So I have a hard stop at 2. But I'm doing this from my car. So, and my daughter's driving me. So be patient with us as we work around that reality. This is kind of the fun part of virtual learning is we can do it on the go. So what I want you to do is put your problem numbers that you have questions on in the chat. And then once it turns 1 o'clock, I have an announcement that I'd like to make at the top of our session today, very quickly. This is our time to go over test 1. So not go over it, but answer questions you may have on test 1. Do you want me to parallel park? I can do my room. It looks like they're actually leaving. Maybe. Okay, it's 1. So I'm going to get started. So here is the sitch. I am doing my best to try to, I'm recording these sessions, but I'm doing my best to try to download them and then upload them into Canvas, into an announcement in Canvas. The problem is that the file sizes are huge. And so I've tried twice to upload the file and it's taking forever to upload. So, so I'm trying, I'm not, it's almost like I'm gonna have to upload it before I go to bed at night and just let it try and upload overnight and see if it actually does it. I tried to embed it in the announcement and it said that the file size was too large. So I couldn't do that. You're gonna just go around and park in a paid parking spot because I don't have time to deal with this. So just park in this lot right here. That go around and go in that lot. I'm trying, but it's not. Even this morning, I tried to zip the file to make it smaller to put into the announcement, and even the zipped file was too big. So I had to have my husband help me with this last quarter in terms of compressing the file. And I eventually got it to work, but it takes some time. So please be patient with me. I'm hoping to get it done by the end of today or first thing tomorrow. So that's what I'm trying to do, and hopefully I'll get it done. So let's get started with questions on your test. And so let's see, what do I have? I'm going to start with the smallest, so that's 2. So I actually did not, usually I do this with my key in front of me, and I did not bring my key with me today by mistake. So I will be doing this off of my copy that has nothing written on it, but I've done this enough times that I know how these problems are solved. So once she gets parked, which now she is, I'm going to pop my laptop up here so that I can have it up there. You're not going to really see me that much, but you don't really need to see me. You need to see my screen because I'm going to be doing, I'm going to be sharing my screen. So let's see. Let me do this screen share. So question 2, the sum of consecutive odd numbers beginning with 1 is always a square number. If you answer true, explain why. If you answer false, give a counterexample. So I think the question here is probably, what do they mean by the sum of consecutive odd numbers, if I'm not mistaken? So the sum of consecutive odd numbers, let me see, I'm going to do my whiteboard. I'm going to look at if it said the sum of consecutive even numbers and what that would look like. Okay. This problem says consecutive even numbers, but I'm going to odd numbers, but I'm going to say what's consecutive even numbers. So the sum of consecutive even numbers, when you look at even numbers, you have 2, 4, 6, 8, 10. Okay. And so it's saying the sum of consecutive even numbers. So it would be 2 plus 4 or 4 plus 6. Okay. Or 6 plus 8. All right. So the problem is saying the sum of consecutive odd numbers beginning with 1 is always a square number. So if I were thinking about that in terms of what I've shown you here with even numbers, the sum of these 2 is 6, the sum of these 2 is 10, the sum of these 2 is 14, and none of those are square numbers. A square number, okay, is a perfect square. Meaning that it's like you can take the square root of it. So 4 is a perfect square because the square root of 4 is equal to 2, because 4 is equal to 2 times 2. Okay. The square root of let's see, the square root of 9 is a square number, right? So
25.
I'm sorry.
25 also be a square number.
It's gonna be, this perfect square numbers are 4, 9. This is 2. 1 is a perfect square number. 1 times 1, 2 times 2, 3 times 3, 16, 4 times 4, 25, 5 times 5, 36, 6 times 6. So they're saying if you take the sum of consecutive odd numbers, that's what the problem's asking. The sum of consecutive odd numbers beginning with 1 is always a square number. So I think what they're looking at though, is they're looking at if you continue the sum. So I don't think they're just looking at just two numbers side by side. They're saying start with 1 and look at consecutive odd numbers, right? So, yeah, all of the odd numbers. And so they're saying, as you continue to add these, does it equal a perfect square? So in other words, if I took 1 plus 3, that's 4. Well, that's a perfect square. But if I took 1 plus 3 plus 5, what's that? That's 9. Is that a perfect square? And you have to keep going. So in math, anytime you have something that doesn't fit that rule, it's false. If you can find one instance where it doesn't work, it's false. If you find that it's true for everything, then it's true. So does that mean you have to go through all odd numbers? No, you'll eventually see a pattern that you can determine, is it true for all or is it not true for all? And then explain why is what I want you to do. Okay? Does that make sense?
How exactly do you want us to explain it? Like, is it okay if we just show the math and kind of use that as our explanation? Or how in depth do you want us to go with that?
Math or words, however you feel comfortable explaining it, but it has to be explained so that I understand that you understand it. So, I mean, I don't have any set type of explanation. Typically, people explain it in words, like they'll say, well, it's not true because this example doesn't work, right? So, or they'll show it. It's not true for this, right? So that's how it works. So in question number 5, can I take any numbers or must it be consecutive numbers? So 5, let me see. 5 says a 3 by 3 array of numbers. No, we'll talk, if you have a question on 5 is a whole different problem. So if you have a question about that, we'll talk about that problem, okay? Separately. So I think I've addressed what's happening in 2.
I have one more question about that. So does it has to start from 1, so you add 1 plus 3 plus 5 plus 7, or can you just add 2 consecutive numbers, 3 plus 5?
No, it's saying if you're the sum of consecutive odd numbers. So is it always equal to a square number? So you would look at 1 plus, like I just showed, 1 plus 3 is 4. That's a perfect square. 1 plus 3 plus 5 is 9. That's a perfect square. Is 1 plus 3 plus 5 plus 7, is that a perfect square? And you have to keep going. And
Okay, so it always starts from 1 then.
you'll see a pattern. But the question is it going to be true for all of them, right? Do you have to write out every odd number? No, because we're not going to have you go to infinity. But you'll see after a certain amount of them, is it true for all or is it not? Is there one that's going to pop up that it doesn't work for, right? Does that make sense?
So, excuse me.
Yes.
For this question, like for the audit consecutive number, the sum of them, if I choose 1, 3, 5, it will be the sum of them is 9.
Yes. Is that a perfect number? Is 9 a perfect number?
Yeah, so I can't do like this.
Yes, but you have to, you're making this conjecture based upon trying it. And I would say go beyond just 1 plus 3 and 1 plus 3 plus 5. Try it for 1 plus 3 plus 5 plus 7. Try it for 1 plus 3 plus 5 plus 7 plus 9. Try it for a few more beyond just 1 plus 3 plus 5, right? And if you keep getting perfect squares, perfect numbers, then you then decide for yourself, is it going to be true for all of them or not? And explain why or why not.
Okay.
You should see a pattern emerge.
Okay.
So I did not see 5 in the original list, but I did see somebody ask about 5. So I'm going to address 5 before I go on. Can I take any numbers or must they be consecutive numbers? No. So here's what's happening in 5. 5 is saying a 3x3 array of numbers is selected from a calendar. If the sum of these numbers is 180, what is the smallest number of the array? So what they're looking at is they're saying take a calendar, okay, any 3x3 array on a calendar. Okay, so you might want to pull out a calendar that you might have, okay? And you're going to be looking at a 3x3 array of numbers, okay? And so you're looking for the total sum of all of these numbers in the days has to total, it says has to total 100. If the sum of these numbers is 180, what is the smallest number of the array? So the smallest number is going to be here. And I've told you to try to avoid using algebra, but
Yeah.
with this problem, you're probably going to have to use algebra. Okay, so let me pull another array over here and show you what I'm going to have to draw it twice because I'm going to have to mark up one and show you what I mean by the other one. Okay. So in essence, if I pull the days off of a calendar, let's just say this is the list. Let's just say this is the first starting tomorrow. This is the first, well, tomorrow's a Friday. That would work. If this is the first and this is the second and this is the third, okay, I'm talking about like October. So this is Friday, this is Saturday, this is Sunday. It doesn't matter what days they are, right?
Okay.
Those don't matter, but the numbers matter, right? So let's just say I started with tomorrow. Then what is this number going to be on a calendar? If I'm a week later than this, what's the date here?
7.
No.
Okay.
How many days in a week?
It's the 8th.
It's the 8th. Perfect. It's going to be the 8th, the 9th, and the 10th. 7
Yeah.
days difference between these. So what's this one going to be?
The 15th.
The 15th, the 16th, and the 17th, right?
Sure.
So we don't know what days we're going to pull out of the calendar. What it's saying is if you took a 3x3 array from any calendar, okay, what's the smallest number going to be if the sum of all of those numbers in that array is equal to 180? So I've told you don't use algebra, but quite honestly, algebra is what you're going to have to use here, right? You're going to have to start out with this day being X. And then what is this day going to be? In terms of
Plus 1.
X plus 1. And this is going to be X plus 2, right?
Yes.
And what is this going to be?
X plus 7.
X plus 7. And X plus 8. And X plus 9, right? You get the drift. Once you find all of those, I'm not going to fill it all in for you people. I don't do all your work for you. Okay. Once you fill all these in, the sum of all of those is equal to 180. So X plus 1 plus X plus 2 plus X plus 7 plus, okay, you get my drift? Is
Yes,
all
yes.
continues, it's all equal to 180. Well, we can combine like terms because we have all these X's, right? And we have all these
Yes.
whole numbers, so we can combine the numbers and we can combine the terms. So right here, just this piece, I have 1, 2, 3, I have 4 X's plus 10. Okay, so you're going to combine all the X's, combine all the whole numbers and solve for X. Okay. And that's going to be your smallest number of your array. That's going to give you a sum of all of those days being equal to 180. Okay, I'm done with that one. I'm going through these quick because I don't want to keep them up here too long because they are hints for you. Okay, that's my job, to give you hints.
Okay.
Number 8. Number 8 is popping in here, and that was before 9 because I saw 9 earlier. Yeah, so I'm gonna look at number 8 now. So number 8 says, what kind of reasoning is used to form a conclusion that is based on a series of experiments? This one you're gonna find from your reading. I don't have any hints to give you on this. There's two types of reasoning. And what are they?
Inductive.
I can barely hear you. You're gonna have to talk to me today, people, because chat is hard for me to go back and forth in the present environment I'm in. So I heard,
Induct-
I heard
uh,
deductive. Did I hear deductive?
Yes.
Deductive and what else?
Inductive.
Inductive. So you got to pick one that this describes. That's all that is. Okay, that's all you need. It's either one or the other. So that's 8. 9 is a little more difficult. 9 we talked about on Tuesday. So whoever's asking about 9, you must not have been here on Tuesday, because I told you there was going to be a problem like this on the test, and it was in the homework. And so you needed to pay attention to that. So there is a formula that I shared. It was actually in, we talked about it the other day. So to find the sum of numbers through a certain amount of numbers, this was actually in your lesson. We actually looked back at the lesson because there was a try this about this type of problem. So if I want to find the sum of numbers 1 to 100, there were a couple of different methods to use. They had a method where they drew in your lesson, they drew an array of 100 boxes, and they had stair steps that they went up, and half of the stair steps took up this square, right? So there's half here and half there. And that was a little confusing to me. Maybe it worked for some of you guys on a visual level, but there was also the rainbow method of attaching these numbers. So, and here's the 99 plus, so this plus this, and keep going. So each one of these was 101. So 100 plus 1 is 101. 99 plus 2 is 101. So the formula was in being the number of numbers you have. Okay, so we are talking 1 to 100. So we would have 100 numbers times n plus 1 divided by 2. And you have to divide by 2 so that you're taking out the duplicates. Okay, because we're gonna have 50 times, right? That we're in the case of 100, we're gonna do this essentially 50 times, right? Because we have 50 pairs of numbers. So we're taking 100 times 101 divided by 2. And that's going to tell us the sum of all of the numbers from 1 to 100. This problem is a little bit different because it's asking you to find the sum of numbers up to 200 and then back down to 100. So they're saying, what is the sum of consecutive whole numbers that begin with 1, increase to 200, and then decrease to 1? So what you're going to have to do is do this in 2 parts. You're going to have to do it so you're talking about going up from 1 and back down to 1. So break it into parts. Use this formula and find this sum. And then use the formula and find this sum and add those together. And so you plug in. So you're going to have n is 200 times 201 divided by 2 plus, and then do this one. And the sum of those two times of using this formula will give you the sum of all of those numbers. Okay. Any questions?
Yes, I have. I do it in another way a little bit. I make it like the first time 1 to 199, and then
200 to 1?
yeah,
Yeah,
and
that's fine.
that's-
It's the same thing.
Yeah, and plus the 200 between the both sum of 1 to 199 for 2 times.
So you did 1 to 199 2 times and then added 200 to it?
Yes.
That should be fine. That should be
Oh, okay.
mathematically equivalent.
Oh, okay.
Yeah, it's just a different way of looking at it, and that's fine.
Okay.
Okay, next on the list, let me see the chat. I gotta look. We did 8, we did 9. I thought I saw 11, and then 15. 2 people asked for 15. So 15 must be a very difficult problem. So let's look at 11 first. So 11 says, consider the following pattern is the 200 and so this is the pattern. Is the 215th square shaded? Explain why or why not. So do you have to continue this pattern out 215 times? No. You have to look for a pattern. If we have time, can we look at 13? I think we'll have time, yeah. So you have to look for a pattern. So we've got shaded, 2 non-shaded, shaded, 2 non-shaded, shaded. So let me recreate that pattern over here. So we've got shaded, 2 non-shaded, shaded, 2 non-shaded. I should just do this differently. Hold on. Erase. I've got a shaded one. I've got 2 non-shaded ones. I've got a shaded one. I've got 2 non-shaded ones. And then I've got a shaded one. Okay. I'm going to take off this last one. Okay. Oh, I didn't mean to do that. Darn it. Oh, let me do it again. Darn it. Shaded, non-shaded, non-shaded, shaded, non-shaded, non-shaded, shaded. Okay. So how many do I have here? I have 1, 2, 3, 4, 5, 6, 7, right? So I've got 7 total. And of those 7, I have 3 that are shaded. Okay. They want to know, is the 215th box shaded? What strategy can you use to find that without drawing 215 boxes?
Arithmetic.
Mathematics. So, Balsam, how would you do that?
So let's do 1 minus 3, it will be 2. Or 3 minus 1, it will be 2. And to see like the difference commons difference, sorry.
I'm not understanding the 3 minus 1 equals 2.
Yeah. And after that, if you look at it is.
Oh, because you're looking at the 3 here.
Yeah.
And you're saying if I take 3 units and I subtract 2 of them, I have 1 shaded.
Yeah, like use it arithmetic way.
Okay. So at some point, are you dividing? That's my question.
Would it be, would you do like 215 divided by 3 since every third square is shaded basically?
So at some point, you're going to have to divide. Whether you're going to divide by 3 to see how many groups of 3 you have in 215, or whether you're going to divide by 7 to see how many groups of 3 or 7 you have in 215, you're going to have to divide at some point. And so you're going to have some left over. So for example, if I divide 215 by 3, okay, I'm going to have 3 goes into 21 7 times, 3 goes into 5 1 time with 2 left over, okay? So I'm going to have 71 groups of 3. Okay. And then I'm going to have 2 left over. Okay. You're going to have the same thing if you divide by 7. But then from that, you're going to have to determine, okay, if I have 71 groups of 3, then how many are shaded in that 71 groups? Well, there's one shaded in each group, right? So that you have to check, you have to see. So I would do this math, but then I'd also check it with dividing by 7 and make sure that you're coming up with an answer that agrees between the two. But there's ways to do this without having to draw out 215 boxes. That's the whole plan of this homework, is to help you to strategize. How do I problem solve without having to carry something out way out, right? Because we don't want to do that. We don't have time for all that. Nobody has time for all that. So
So
that's,
I did oh, sorry.
you have time, Shannon?
No, I said, go ahead. I
No,
didn't mean to interrupt you.
no, that's okay. Go ahead.
So that question, I did it the same way. I divided by 3 because I saw that every group of 3, there was 1 shaded. And I
Uh-huh.
got the 71 with remainder of 2. The part on that I kind of went around on in my head is whether or not those additional 2 were the clear boxes, you know, those 2 at the end.
Well, but you think about, you're starting with a shaded, right? And
Right.
then the 2 after that are not shaded, right?
That's what I thought. Yeah.
So that's
Okay.
your pattern. So
Yeah.
yeah, so that's your pattern. So
Okay.
I think you're on the right track.
Okay, good. Thank you.
And somebody said 13. Okay, so the hard part about 13, so 13, you have to look at numbers, okay? So with 13, I don't think I can write on this. I can write on this. Here, there's 1 box, right? How many boxes are in this one? How many cubes are in the second one?
Four.
4. You can't see one, right? It's the one that's underneath this corner one. So there's 4. There's 1, 2, 3, and 1 on top of that corner. So in this one, there's 1, 2, there's 1, the ones we can see, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 2 in the back, right? Do we see a pattern in those numbers? This is what you're looking for, people. You're looking for patterns. So what's happening with these numbers? If we look at these numbers, we just talked about this type of number in the problem, a previous problem. 1, if I break 1 down, is 1 a perfect number? Is it a perfect square?
No.
Yeah, 1 times 1 is 1. 2 times 2 is what?
4.
3 times 3 is?
9.
Okay, look at this. This is the first shape. This is the second shape. This is the third shape. So this is 1 times 1 is 1.
We're
2
not seeing your screen.
Oh, sorry, you're not seeing my screen. That would help.
No worries.
I'm showing you things and you're not seeing it. I'm sorry. So let me say new share. New share my screen. Okay, wait, I don't want my screen. I want that file. Okay, so I'm writing on, can you see this?
Yes.
Yeah, we can see it now.
So the first shape has 1 cube, 1 cube. Second shape has 4 cubes, 4 cubes. Third shape has 9 cubes, 9 cubes, okay? But we said 1 is equal to 1 squared, right? 4 is equal to 2 squared, right? 9 is equal to 3 squared, right? Test it. Draw the 4th one. Just draw it. You're going to have, if we add on 1 to each one of these, and I'm not going to draw it because I suck at drawing, right?
16 squares.
It's 16 squares. So it's 16, and 16 is 4 times 4, right? Or 4 squared. Sorry, I should have wrote 4 squared. So then the question is, how many cubes are in the 15th figure? Well, we got it. People, you know it. You could take it right off of that. That tells you right there. There's a pattern. Follow the pattern. Now I don't know how to erase this. Let me see if I could go up here to my whiteboard and get my eraser and bring it over to here. I don't know if I can. Let me go back over to here. No, I can't erase. Oh, you know what? I can do it up here. Erase. Yay. I'm learning things today, people. Just like you're learning things, I'm learning things. It's awesome. Okay. Next was 15. 15 says, how can a chef, were there ones besides before 15? Where's my chat? 12. Oh, somebody wanted 12. Also wanted 12. Let me go back up. 12, 15. Okay. So I skipped past 12. So let's go to 12. 12. Why are you making me go back up? The third number in the third row of this triangular number pattern is 7. If the triangle of numbers is continued, what is the third number in the 17th row? Okay, here you're still looking at patterns. You're looking for patterns. So the first row starts with 1. The second row is 2, 3, 4. So you're looking at the third number. So this is not Pascal's triangle. Do not confuse this with Pascal's triangle. You notice the pattern is they're taking one number and then they're taking the next 3 numbers and then they're taking the next 5 numbers and then they're taking the next 7 numbers. So you should be able to find a pattern in that. So in other words, the first row,
Excuse me, we do not see your screen.
dang, I keep forgetting to share my darn screen. Okay. I keep going between things. That's the problem. All right. So here we are. Can you see that?
Yes.
So in this row, now it's not letting me draw because I'm not in my drawing mode. Okay. So in this row, there's 1. Okay. In this row, there's 3 numbers. In this row, there's 5 numbers. In this row, there's 7 numbers. Okay. Are we seeing a pattern?
Yes.
So if they're asking what is the third number in the 17th row, okay, you should be able to figure out how many numbers are going to, you should be able to continue this pattern without necessarily looking at numbers and find out how many numbers are in that row, okay? Add back up to see how many numbers in total you had before that, and then what would the third number be? These problems are going to take you some work. It's not going to be always just intuitive and easy, okay? And you have to be prepared for that. So, but that's your pattern that you see right there, and you can continue that. So how many numbers are going to be in the 5th row? In the next row that we don't see? How many?
9.
9. Okay, and we can keep going. But now, like if it said the 10th row, let's just say it said the 10th row, then the 10th row is going to have 11 numbers in it, but I don't really care about the numbers in the 11th row. I know that this one had, this had 1, 3, 5, 7, 9. So it had, let me see, 16, 21, 22, 25 numbers. So at the end of this should be 25. Okay. Which makes sense because if I take 16 plus 9, it's 25. Okay. So then I could say, well, this is going to start with 26 and 27 and 28. So 28 is my third number. right? So that's how you're gonna work that one.
So
So
that's mean this is not Pascal's triangle.
not Pascal's triangle at all. Because Pascal's triangle is talked about in one of these earlier problems. Pascal's triangle is the one that says, this is 1 and 1, and 1 and 2 and 1, and 1 and 3 and 3 and 1. That's Pascal's triangle, where this number is the sum of these two numbers. Okay, and this number is the sum of these two numbers. That's Pascal's triangle. This is not Pascal's triangle that you're looking at down here. All they're doing is taking the actual counting numbers and putting them in a triangle. So the last one to look at, why am I not being able to scroll? Come on, computer, work with me here. The last one on your list is number 15. 15 always trips people up, okay? How can a chef use a 10-minute hourglass and a 6-minute hourglass to time vegetables that must steam for 14 minutes, okay? So the key to this problem is, what is the difference between 10 and 6?
4.
There you go. That's the only hint I'm going to give you. Find a way to use those hourglasses with that difference of 4 minutes. And you have to tell me, don't just tell me how to turn the hourglasses, but tell me at what point does the chef start steaming the vegetables? Or end steaming the vegetables? However you decide to use those hourglasses. But the key to this is that the difference between the 10-minute hourglass and the 6-minute hourglass is 4 minutes. So find a way to use those hourglasses and tell me at what point, tell me how to turn the hourglasses, when to start it, which ones to start, how long to turn, when to start the vegetables. That's what you have to tell me in the answer to that problem. But my only hint to you is that 10 minus 6 is equal to 4. So you have a value here and a value here that somehow make it to this, but you've got to tell me how. Okay? So bear with me in trying to get that video loaded for Tuesday's session, as well as this video today, because I know you were here, but you might want to rewatch it. These videos are very long, and it takes a long time to download them. And then they are very difficult to upload into Canvas. So I'm doing my best, and I'm sorry that my best is not really working right now. Because I tried it yesterday, I tried it today, and I'm having such difficulty with it because it's not wanting, you know, the file is just too large. It keeps saying the file is just too large. So, any other, let me erase this one too. Any other questions for me? Make sure I erased everything. Okay, stop share. Anyone who understands 5, please message me if you don't mind. I thought I had it, but seeing the way it was done in class, I was wrong. So what was 5, Shannon? Now I'm curious. 5 was a 3x3 array is selected from a calendar. You didn't see the explanation for that?
So I saw it, and as you guys were going through it, I realized must have read it wrong. But I'm coming out with a number that doesn't come out to a whole number. So I'm thinking I must have just not caught something.
Yeah, you have to have, it's gonna have to be a whole number because it's gotta be a calendar.
Right.
So-
Yeah.
So just be real careful in your 3x3 array. Start with that that x plus 1, x plus 2, and then you're a week later, so it's x plus 7, x plus 8, x plus 9. Then
Oh,
a
it's X plus 8. It would be X plus 8, X plus 9, X plus 10, right? Because it's a week later. I think that's where I went wrong.
Yeah, that's the second row. And then you've got 3 for the third row that are now x plus what? Now
Got
x,
it. I think I found it.
yeah.
I put 7 as the second row's X instead of 8. So
Yeah,
that's what it
that'd
was.
be
Thank
8
you.
because that's 7 days in a week. Yeah,
Right. Got it. Thank you.
you're welcome. All right, people, that's all I have for you today. This test is actually one of the shorter tests in this quarter. So we don't have as much to go over. And I'm going to make it on time to my dentist appointment. How is that going to work? Yay. And hopefully this file won't be so huge. And so I can upload it pretty easily. There's that too. There's lots of positives today. Cassidy, that's great. Thank you. You know, here's what I'm going to tell you, people. I am teaching, let me see, 5 classes on 3 campuses. So when I do something for you, when you ask me something in email and I do it for you, you don't have to send me an email to thank me. I'm just saying, I know you're thankful. I appreciate it, but it clogs up my inbox. Okay. And it's just another email I have to take and put my eyes on. So in the interest of reducing my emails, just be thankful on your own. I know you're appreciative of what I do. Just send me the request. I will email you back and let you know that I have fulfilled the request, but you don't have to thank me. Okay. You can wait and thank me during class time where we meet. But just don't thank me, because the last 2 days I've gotten like 10 emails of thanks, and it's like, okay, great, but that's 10 emails I really don't have time to look at. So, and I know that probably sounds really rude. It's like, well, we're being kind. We're trying to thank you. I very much appreciate that. But it's too much. Okay. So, I'm glad you said thank you, Cassidy, because it reminded me to remind you guys, don't thank me. When you ask me to do something through email, don't send me an email to thank me, because it just takes too much time. Jennifer, was there an exit ticket for 1.2 or just 2.1? Let me look really quick, because I have, I can look that up really quickly. Just give me a second. There's not an exit ticket. I can tell you this, there's not an exit ticket for every unit, for every section. So if you didn't see one for 1.2, there probably wasn't one. But let me see. No, there are exit tickets for 1.1, 2.1, 2.2, 3.2, 3.4. So they're not every section. So if you see an exit ticket, there's just an exit ticket for that section. It's not for every section. Okay. So in 2, I think there's 3 sections in 2. So there's an exit ticket for 2.1 and 2.2, but not 2.3. So don't expect an exit ticket for every section. Just when it applies, it'll apply. Anyway, we can open the exit tickets before the day they are due. I go to the library to print, and they are not open every day of the week, one of which being Monday. No, you can do them electronically. You can pull it up on your computer and write your answer in like I was writing in my Word document. You can draw your answer in and then save the file and upload it. You don't have to print it out unless you want to print it out, because they're only like 1 question. So no, they're due the day that I don't want to change that, because that's gonna cost me a lot of work and time to change that, because I got all of those already set up in the last couple of days. So no, they come available to you on the morning of the day they're due, and they're due that evening. So I'm sorry, Shannon, that I can't accommodate that, but you can definitely do them electronically. Okay. All right. Have a good day, people. Have a good weekend. I will see you, I think, if I remember the calendar, next Thursday, maybe next Tuesday. We'll see. Okay. Take care.
You got upset with me in front of all your students.
Sorry. Well, it was just, I can't help you park. I was getting nervous about you parking and